Okay, so this is the setup, the general setup for your wind tunnel. Okay, this is your 3-component balance. Okay, there's a digital readout for the 3-component balance here, but it also sends all the data to a computer for the data acquisition portion. These are your liquid manometers here. Okay, as you can see, the first two come from your pedostatic tube, which is over here. The one that's coming in out of the top is your total pressure. The one that's coming out of the side is your static pressure. Okay. Basically, you see here that you have all these columns of water. Okay. Your static pressure is again going to be negative, like we demonstrated with the Venturi demonstration over there. So your total pressure, which is positive, is actually going to push down on the column of water. So this manometer here is going to be pushing down, okay? And since all the other ones are static pressure, they're going to be rising up, okay? Now, it's a little bit confusing to think about, but you have a vacuum pressure, like let's say you're drinking through a straw. That column of water is rising based on the vacuum that you create in your mouth. So the atmosphere has a greater pressure than that vacuum pressure you're creating in your mouth, which causes the liquid to go up. So similar thing in this scenario. Effectively, all of your static values that are going up are actually should have a negative sign convention. Okay, so again, liquid goes up, it's given a negative sign convention. Liquid is pushed down, it's given a positive sign convention. Okay, so yeah, what I'm going to be doing is varying the angle here, this dial here. I'm going to be filming these manometers. You're going to read these manometers, and that'll allow you to find the pressure distribution over the airfoil as well as your friction velocity. Now, the airfoil in here is about 6 inches long. The test section has a height of about 12 inches, okay? So in an ideal scenario, we would have a much larger test section than the airfoil is wide. But because, we have limited space in the fluids lab, the airfoil in there actually, as it changes angle of attack, can interfere a lot with the sidewalls, okay? So that can change your pressure distributions as well as your coefficients of lift, coefficients of lift and drag at higher angles. Another thing it will actually do is it'll actually stop some of the flow. So even though it shouldn't be changing the speed too much as you change your angle of attack, it will actually end up changing it slightly. So for each angle of attack, it will be helpful to find a velocity for that angle of attack. It'll make results a little bit more accurate. Yeah, that should be about it for the explanation.